Hello everyone. I just wanted to give us a quick video on electrolytes. Okay. As far as electrolytes goes, an electrolyte or an electrolytic solution is a solution that has a substance dissolved in it. That substance is probably going to be ions, most definitely be ions. Okay. So an electrolyte is something that when dissolved in water, that solution, the resulting solution, will conduct an electric current. Okay? So an electrolyte is a substance whose aqueous solutions contain ions, and a non-electrolyte is an aqueous solution that does not form ions, therefore will not conduct an electric current. So as far as electric current goes, we see electricity being formed in electrolytic solutions, and no, if I were to move this down here, if I were to do this, there is no electricity or no electric current that can be conducted by a non-electrolyte. Okay? Now, moving a little bit further, there are three classifications of electrolytes. There's strong electrolytes, there's weak electrolytes, and as you just saw, there are non-electrolytes. So what I'd like to talk about first are going to be the strong electrolytes. We'll spend most of our time on this. Okay? So a strong electrolyte is this, okay, as you see in red on here, it's a strong electrolyte will completely ionize, in other words, form ions when dissolved in water. Now, that's an important definition. Completely ionize, complete ionization, okay? So you start with ions, they're locked in bonds, in an ionic bond. Those will dissociate to form ions when they dissolve in water, okay? Now, the important thing here to remember is it doesn't matter how much dissolves. What matters in order to get a strong electrolytic solution or a strong electrolyte is, again, not how much dissolves, but whatever dissolves, whatever quantity dissolves, it must all form ions. Okay, that's a strong electrolyte. Okay, so these are two examples of strong electrolytes. We have NaCl. That's, of course, table salt. When you dissolve that in water, you end up with two ions. You have a cation here and an anion here. Okay, this solid substance will form aqueous. Here, let me erase this a little bit here. This will form aqueous compounds. It's an AQ. Here, let me make that a little bit better. It looks like this, AQ, but I'm just terrible at drawing that. So that's AQ for aqueous. Some people say aqueous. Okay. Now, you'll notice that calcium nitrate, also a solid crystalline ionic substance, a powder or it looks like a salt. Actually, all ionic substances are called salts anyway. That forms calcium ions. That's 2 plus cation. And notice you have two nitrate anions. Okay, so all of this stuff has become dissolved ions. Okay, now you got to remember that as we move through this video. Okay, so the calcium nitrate becomes all ions, the sodium chloride becomes all ions. Those are strong electrolytes. Now, they're saying, no, not all ionic salts are strong electrolytes. It's a pretty good bet if you picked one, it would be. Okay, but I just wanted to say that not all ionic salts, and again, what are ionic salts? This is an ionic salt, this is an ionic salt. Okay, to just explain that one step further, a salt is a generic name for anything that has an ionic bond. Okay, so they form nothing but ions and therefore can conduct an electric current. Okay, moving on with strong electrolytes, you'll see some special points about strong acids. So we're going to be talking about strong acids here as the course goes on. But anyway, strong acids, and you'll notice I have listed six. The H2SO4, that's sulfuric acid. HNO3 is nitric acid. HClO4 is perchloric acid. HCl is hydrochloric acid. HBr is hydrobromic acid. And HI is hydriodic acid. I say memorize these. It's a very good idea to memorize the six strong acids because the six strong acids also represent six strong electrolytes that you need to know. Okay? Therefore, we will say that any other acid listed, and some teachers include a seventh acid, which is called just chloric acid, which is HClO3, but these six strong acids are strong electrolytes. Okay, they will completely dissociate to form ions. You need to know that. Okay, completely dissociate to form ions. So how do we write these? Pay attention to this. Bullet point here, strong acids should be written as HNO3 aqueous. Why AQ? Because they completely ionize. Notice HClO4 aqueous, HCl aqueous. They're completely soluble and they will assume complete dissociation. Dissociate means to break apart or to break up. Okay? So they will break apart into nothing but ions. Now, those are acids, 6 strong. I would memorize those. Okay? Now, I have listed in the notes that group for bases, we're a little bit different here. I've listed that group 1 metal hydroxides are strong bases and heavy group 2 metal hydroxides, okay? Now, just be careful here. This is concentration dependent, okay? In other words, the stronger, well, I'll just leave it at that, okay? Group 1 metal hydroxides. So in other words, lithium hydroxide, sodium hydroxide, potassium hydroxide are 3 that I would know. If I were you as a student, I would know those as being strong bases, therefore strong electrolytes. Okay? Now, let me move this up here. Real quick, note, acids will produce H plus in solution, bases produce OH minus in solution. That's just a quick, for example, make sure you guys know what's going on there. Okay? All right, I just got rid of something, so I got to just get that back. Here we go. Okay, so moving on, I think I have one more slide for strong electrolytes. Like I said, we do spend some special time, most of our time is dealt with strong electrolytes, but sulfuric acid is special. Notice it's got H2SO4. Check this out. H2SO4, does that mean it produces 2 ions of H pluses? So the question says, the statement says it has 2 H pluses to lose, but not easily. Only the first H plus, is lost easily. The second is more stubborn. It doesn't want to lose that second H plus. Because of this, you would think that that second one isn't very soluble, so we would say H2SO4 is not a strong electrolyte, but the problem is that first one is lost so easily. This first H plus, this equation right here, is such a strong dissociation reaction. We say that sulfuric acid is a strong electrolyte. We're okay with that. Everything works out. So let me explain this a little bit here. Notice the first one, as you can see, let me just change things up a bit. You'll notice that this first reaction right here, it loses an H plus in a dissociation reaction or dissociation process. Notice the single arrow here, okay? That single arrow pointing to the right says this is a good strong reaction as it proceeds towards the products, okay? Now, let's take what's left over. This is left over. That's represented down here. These two things circled in red are the exact same thing because now we have another reaction, another process, I suppose, where HSO4, not only does it become this, H plus and SO4 2 minus, but since these two like each other, more on this as the class goes on, it comes back. It comes back to the left. So not only does this exist in solution, but also some of these as well. This two-sided arrow that you see here, this two-sided arrow pointing to the left and right here, that's called an equilibrium. An equilibrium means that both this side of the equation and this side of the equation, or the substances on those sides of the equations, exist relatively simultaneously. Okay? They can't decide, is it going to become all these? Is it going to become all these on the left? It goes back and forth, in other words. That's what the two-sided arrow says. This, not so much. This says, yes, we're going to the right. We love it. We will be those. Okay? All right, continuing. The rest of our discussion is a little bit more simple. We have weak electrolytes. Okay? Now, when we talk about strong electrolytes, let's go back to that for a second. They really conduct an electric current very strongly. Okay, you can get zapped, you can get electrocuted by a strong electrolyte if you are bathing in a bath and you throw in some soaps and stuff in there, and all of a sudden you get zapped by a hairdryer that all of a sudden gets knocked in there too. That's a very dangerous situation. But weak electrolytes are not quite as dangerous, and again, don't try that at home. But weak electrolytes only produce a few ions when dissolved. Okay, so if we go to the root of this, if the ions are what helps to conduct an electric current when dissolved in water, weak electrolytes, if they don't produce as many ions, if they don't produce or only produce a few ions when dissolved, this is not so bad. Okay, there's a demonstration I'll show you in class with electrolytes and a light bulb. So if you go to a strong electrolyte, the light bulb is very bright. It's like lights up the whole room. If I put a weak electrolytic solution in there, the light bulb is dim. It's not so much. Why? Look at, we have another equilibrium arrow. So I want you to know two weak electrolytes, okay? This is one of them. HF, hydrofluoric acid, is a weak electrolyte. HF, hydrofluoric acid, weak electrolyte. Know that one. While I'm on the topic, acetic acid is right here. Know that one. That one is a weak electrolyte. That's the second one I want you to know. Actually, there's a third one. I apologize. I just saw it now. The third one is ammonia. Ammonia is the only weak electrolytic base I want you to know. Okay, so to recap, 2, 1, 2 weak electrolytic acids, weak electrolytic acid, weak electrolytic base. Okay, 3 to know. Those are the only ones I want you to memorize there. So what's going on here? Again, we go back to the equilibrium. It can't decide what it wants to do. Okay, so it goes back and forth. And this has to do with strength of bonds. But again, we have to get into the class more to talk about that. But again, just to explain, HF becomes H plus and F minus. But then these things recombine to give you HF. So actually we have 3 things in solution. We have HF, which becomes this and this. And then these things recombine to form this again. Okay, so 1, 2, 3 things in solution. Okay, all weak electrolytes work this way as existing in equilibrium. Okay, that's basically it. Notice this is the exact same thing. Okay, except now this is the dissociable, the dissociating H plus. Very weird how acetic acid is written, so don't sweat that too much. We'll get to that later. Notice the weak base. Weak base does something funky with water to become this, and look at, there's the essence of a base right there. I mentioned that a couple slides ago. OH minus, hydroxide ion, is the essence of a base. That's the ion that forms a base. Okay, so make sure you know those 3 reactions as far as weak electrolytes goes. Okay, now a real quick word on weak electrolytic salts. There's a ton of them, or there's at least enough of them that we need to worry about, but again, more on that later. Okay, the last slide that I want to talk about in this video is that are something called a non-electrolytes. Now, non-electrolytes are things that don't form any ions whatsoever when dissolved in water. So you have to dissolve something in water to form a non-electrolytic solution. They don't form any ions. The best and easiest and most universal example I have is sucrose. If you don't know what sucrose is, I'll tell you right now. It is table sugar. Okay, so sugar, solid, becomes sugar dissolved. Aqueous means it's been dissolved in water. Sugar is really, really soluble. It's super soluble. But let's go back to our original slide, our original definition. No matter what dissolves, it has to form ions. Well, this doesn't form any ions. So even though you can get truckloads of sugar to dissolve in water, it doesn't form any ions, so it's a non-electrolyte. Okay? That's all I got for that. As far as non-electrolytes goes, weak electrolytes, strong electrolytes. Questions, let me know. But I'll sign off here.